Hello again, students. This will be our second video for the day. Here, notice that all of our problems start with a log in the problem. So the difference is the set that you just finished start with the exponential in the problem. So really, we're just going to work backwards this time. Check out example number 4 with me. The variable v is inside the log, so I need to get rid of a log base 7. Well, in what we just finished, to get rid of an exponential base, you need a log base of the same. So it works both ways. To get rid of a log base 7, you need an exponential of the same base. So I need to rewrite this raised up as an exponent with a base 7 on both sides. An exponential base 7 and a log base 7 will cancel each other out. So here I'm left with v equals whatever 7 to the power of 49 is. I guarantee that's such a huge number, our calculator is not going to be very helpful. Calculator, 7 to the power of 49 is enormous. Check out that number. I have no desire to write that number down, so I think I'm just going to leave my answer as 7 to the power of 49. Probably should have written up a different problem there. Oh well. Next example. Check out number 5. Here's the log, and follow those parentheses all the way down. Everything in the parenthesis, everything in the base, all of that's part of the log. The only thing that's not part of the logarithm is this 5 out front that's multiplying the logarithm. So we got to get rid of that first. To get rid of a multiply, we'd use a divide. They're inverses of each other. So now I'm left with log base 2 of b plus 4 is equal to negative 5 divided by 5 is negative 1. Now I'm to the point I need to get rid of the log base 2. To get rid of a log of base 2, I need to raise it up as an exponent of the same base. A log base 2 and a base exponent, the base of an exponent, will cancel each other out. Now whatever I do to one side, I do to the other side, so I've got to raise up negative 1 as well. Remember, we've got to keep our equation balanced, so whatever we do to one side, we do to the other side. Here, the exponent and the log cancel each other off, and we've got b plus 4. And here we've got 2 to the negative 1. Now, maybe if you just recently reviewed your negative exponent rules, you already know that that's going to be equal to 1/2. If not, no big deal. Grab your calculator and type it in. 2 to the power of negative 1 is 1/2. Sure, you could write that as 0.5 if you want to. I already know that's going to be a question. Last thing to do, get rid of the b, subtract 4, subtract 4. Subtraction is the inverse of addition. And we're going to get negative 3.5. You could write that as negative 3.5 if you want to. One more example to do with you. Check out this example 6. There's a lot going on there. Maybe write a little smaller. First, let's recognize what's part of the logarithm. The logarithm starts with the word log and goes all the way to the end of the parentheses. So there are 2 things in the equation that are not part of the logarithm. One is the negative 7 out front that's multiplying, and the other is the minus 3 towards the end that is subtracting. According to the order of operations, we want to get rid of any adding and subtracting first, then any multiplying and dividing. So I need to get rid of the minus 3 first. I'll add 3 to both sides because adding is the inverse of subtracting. So I'll have negative 7, then all the log information, log base 6 of 4x plus 3 is equal to negative 3 plus 3 is 0. That's going to make this division pretty easy. To get rid of the negative 7 that's multiplying the log, I need to divide. And 0 divided by anything is still 0. So I have log base 6 of 4x plus 3 is equal to 0. Now I'm down to the part that's new for us. We need to get rid of a log base. In order to get rid of a log base 6, we need to raise it as an exponent because an exponent and a log will cancel each other out. So base 6 of a log base 6 will be inverses of each other. They'll cancel each other out. Whatever we do to one side, we have to do to the other side. So I have a base 6 on both sides of the equation now. This base 6 and the log base 6 cancel each other out, leaving me with 4x plus 3. And 6 to the power of 0, don't get tricked. 6 to the power of 0 is not 0. Any number to the power of 0 is equal to 1. Any number to the power of 0 is equal to 1. And now we have a pretty simple linear equation to finish out. I need to get rid of the plus 3, use the inverse, so subtract. I've got 4x equals negative 2. To get rid of a 4 that's multiplying x, we would divide. So finally, x is equal to negative. Negative 2 over 4 reduces to negative 1/2. Okay, here's all my solutions. I know we have some new things going on. We are really good equation solvers, so keep trying. The practice that goes with these 3 examples starts at number 7. Starts out pretty easy and works its way to something much more difficult. Ask for help, ask questions, show your work. Good luck.